My name is Larry Mead. I'm with I'm a principal program manager with Azure Engineering. I work in a group that's called the Critical Infrastructure Group. In essence, we try to take what are the hardest workloads and see how to best host those in Azure. So I've been around Microsoft over 25 years, so I've seen a lot of things come, I've seen a lot of things go. But prior to that, I did spend over 17 years working on mainframes, IBM and Unisys, but also enterprise Unix systems. So I do have the background of both programming and working with systems to be able to know how they can best be hosted into Azure. So I've actually developed my first programming language was Fortran, moved on to assembler and then into COBOL, kind of a backwards thing, but that was the way my career went. And then came over to Microsoft, and the fact that I had experience with mainframes, I never really got away from them, even though I came to Microsoft, because everyone was coming to me to understand, well, how can I integrate with this mainframe? And then later, how can I actually move things off the mainframe? And especially now that we're in Azure, that's becoming more and more of a reality. So my email address, that if people want to send me any questions, comments after the session, is Larry Mead, that's LARRYME at Microsoft.com. So with that, I'll go to just discuss briefly what we're going to cover, talk about the platforms that we have. Then we're going to talk a little bit about, why are people moving off the mainframe? As Ron mentioned, these applications been around a while. They wouldn't still be around if they weren't providing business functionality. So what are the goals that people have? And then what are the options for potentially taking that path and moving to the cloud on Azure? Then we'll get into a little bit more of the details of how you would actually do that based on both your goals and the options that are available. And then lastly, got some summary that we'll talk about what a typical transformation journey might look like. And also I've got a bunch of links that I can share, which I'm not going to go through the links, but since we're going to share this content with the folks on the webinar, those links will all be in the presentation. So I'm going to jump right into the platforms that we cover. So in our terminology, a mainframe really is two types of systems. It's an IBM Z system, or it's a Unisys ClearPath system. And even within there are different types of systems. There's an IBM, you've got ZOS, that's the most common mainframe system. There's also something called ZTPF, that's a transaction processing facility. There's a ZVM, that's a virtual machine platform that a lot of mainframes run. I can run ZVM to then run multiple copies of ZOS, for instance. ZVSE is a smaller mainframe system. And then finally, Z-Linux is actually, you can run with ZVM, or you can actually have specialty processors. So they're all things that you're potentially moving off your mainframe. With Unisys, that's actually two different types of mainframes. MCP is the classic Burroughs system, and OS 2200 is the classic Sperry system. So we have to cover those. Then the other mid-ranges, that's where you get into the IBM Power systems. That covers what's currently called the System I, which is a lot of people know is the AS400, and it runs OS 400. But there's also AIX and Linux that can run on the Power system. Then the other enterprise Unixes that we cover are Sun Spark, which now Oracle owns Sun, and Fujitsu, which is the one that's providing the larger systems, and also HPUX, which were things like Superdomes would run those. Now, what all these have in common? Well, they can all be re-architected in and rehosted into Azure. And the ways they can be done is typically 3 ways. You can rehost them, meaning you're not wanting to change them much. They provide the business functionality that you need. You can refactor them, meaning that you do want to change the language that it's written in. For instance, you can't find COBOL programmers anymore. You can't find PL1 programmers anymore, or especially you can't find assembler programmers anymore. Or you might want to re-architect the systems. This is where you simply don't want to maintain the system as it is. Maybe it isn't meeting your business functionality, that sort of thing. And the thing that I want to emphasize is we do have paths for all of these possibilities. Plus, these systems come in a variety of sizes. Mainframes are typically measured in something called MIPS, that's millions of instructions per second. That's sometimes also called MSUs, millions of service units. One MSU is worth about 8.1 MIPS. But I guess my point is that they, as you notice, there's some mainframes can be as small as 100 MIPS. Some can be greater than 100,000 MIPS. So they're quite a bit different in size. And so you sort of look at these, and then you know how you want to have a strategy that you can do to accommodate all these. We talked about hybrid in the last session. Well, if you've got 100,000 MIPS, you're probably going to have to run in a hybrid environment at some point, because it's really hard to do that over a weekend. However, if you've got 100 MIPS, hey, you might be able to do that over a weekend. So there are some differences that you have. Somebody I think needs to be on mute. If they could do that, please, I'd appreciate it. And then so let's go and talk about transformation goals and options. So let's look at why people are doing these things. The first one that's probably the biggest thing is this whole idea behind cost of ownership. Mainframes are expensive. They just are. They may be worth the value to a lot of customers, but they still take up a lot of operating budget. That's especially true if you're in a business that's currently under some kind of a squeeze in profits, or quite frankly, government institutions running mainframes are seeing that right now too. And so just getting out of the mainframe as quickly as possible might be what your goal is. Others might be looking for, okay, I'm moving towards the future. I want to have a public-private option. I want a private option. I want more ISV solutions that are maybe packages that I could work with, that I could deploy, and I could maybe do that in, in a cloud environment. And there's a lot of other options. People aren't developing as many systems for mainframes as they were in the past. So that could be something. Agility, we quite often run into customers who, let's say they've got a system that they have on the mainframe, getting changes into that system, quite often there's quite a backlog there. So getting that into something like either Java or C#, putting that into a more agile development environment. These are things that can be done with moving it into cloud environments. That could be a way of making this go more quickly. And then the last piece I'll cover very quickly is the skills. I've been around since the late 70s working on mainframes and Windows. That means I'm not going to be around forever doing it. Eventually, I want to, retire. When people do that, you're going to lose folks who have the skills to do these types of things. So, finding where you can have that refresh of the talent is very important to a lot of customers we have. So, Microsoft, we've been actually doing this for a while, moving off of mainframes. We've had a formal program for 12 years. I've been part of that on and off for those 12 years. Last 3 years, very much focused on it. And the way that we approach this is we have people who actually do understand mainframes, have done that before. I work with some of my colleagues that actually hold patents in mainframe systems that IBM still uses today, for instance. So we do have an understanding of the systems, and we also work with an ecosystem of specialized partners. In general, that is not something that's a core, development, capacity of Microsoft. In other words, we don't have a lot of COBOL programmers or PL1 programmers, but we do have partners who do specialize in those types of languages and provide those on platforms that run into that can run in Azure. So we do have those things, and we by taking that number of years experience, we're able to reduce the risk, because the risk is really besides the cost and going to new agility, a lot of customers are worried about the potential risk of moving off the platform. So what we've done is we're taking the experience that we've gained over 12 years in order to be able to provide that. So, I want to, show what are the ways of moving. So we've taken the traditional 5 R's from Gartner. We've actually added an R in there too, and about ways to get off the mainframe. First one that we added in there is called remote hosting. This is where the customer perhaps really needs to get out of that data center. We've got some customers who just need to get out of their data center. They've outgrown their data center. Their hardware needs to be refreshed. Whatever the reason, sometimes we do have partners that we work with that are, have high-speed connectivity into Azure, that they can then rehost the mainframe in their environment and then turn around and provide connectivity into Azure, and also give them the option to move over time into Azure. So they have these flex contracts that doesn't matter where the system is being run. So you could start off with it still being on ZOS, but go into Azure as you go. So that's something that we're introducing. IBM's probably the largest remote hoster, but we have other partners who do that and will work with us to have these flex contracts. Of course, retire is the one you're just getting rid of it. Retain is essentially wrapping applications. That's where integration and hybrid strategies come into very much into play. And we do have technologies like host integration services that work as part of being able to integrate in with the mainframe, and then some of that technology, for instance, can be used in some of our Azure features also to allow connectivity back. Replace, we already talked about the fact that ISVs are a main part of this, but I do want to look primarily at the next three: replatform, rehost, refactor. Let me tell you the difference between the three. Replatform in our terminology means that you can actually move the load modules as is over into the Azure environment. There are some partners. There's a partner in particular we work with, and they can take that load module. You don't even have to have the source code. They will convert that load module into x86 instructions, and you can then run that within a Linux environment over into Azure, and you can actually take that and run it in containers. You can even host it in Docker and maybe take that Docker and deploy it into Kubernetes. That just lots of possibilities there. The other one that we talk about, that's the replatforming. The rehost is where we move the COBOL over, but we do have to recompile it. Under those conditions, we have partner solutions that provide mainframe type services. For instance, they transaction monitors like CICS or IMS are things that you can do. The refactor I already mentioned is the way I want to get rid of the language. I want to change that to Java, C#. I then would want to host that on some type of web service within or app service within Azure. And then re-envision is I'm just starting over again. Well, why do customers do that? Well, if it doesn't meet the business need, or We do have a couple of customers that simply their current code base, there's no way they want to replicate that code base anywhere. They want to start again. So those are all and we do cover all those different paths. Those different paths do come with levels of complexity. The more you get into change, the more the complexity, and usually the longer it takes. But there could be, value that's gotten of it. In other words, you get to a more agile environment as you move through the process. So I just want to talk about some of the things that, show that we actually, do provide mainframe class capabilities within Azure. So, from things in the very beginning, like there's things like machine check architecture that was actually brought into into the x86 world with people from our team because that was already available in IBM mainframes. So we worked with our chip providers to then be able to do that, and that has been brought forward. For avoiding outages, there are some things that are called coupling facilities that are within mainframes. Well, and parallel sysplex, that's sort of a scale out functionality of the mainframe and also provides high availability. Well, we can do similar kinds of things in Azure with the way we can configure systems in a much cheaper cost. And if you're doing something where you need to share data, well, we've got Redis Cache available to do some of those things. So, as we go down this system, we do have the manageability. Mainframes, people may or may not know, are quite often virtualized. In fact, a mainframe had virtualization in the 70s. And, a lot of what we do is built on, for things like Hyper-V and Azure, had its inspiration on what the mainframe did. Well, we do provide those capabilities. Mainframes have systems like RACF and Top Secret and ACF2. Those are the mainframe security, systems. We can take those and map them into, we can import them into Active Directory through taking the schemas and extending them, and then have similar capabilities moving forward. Mainframes have capacity on demand. Essentially, when you buy a mainframe, everything's in there. If you want to use more processors, a field engineer comes out and turns it on so you can use it. Well, with Azure, you've got elastic computing, which is even better. So we've got all of these things that exist in the mainframe, but we also have a few things the mainframe doesn't have. The modern development environments, and if you're getting into the modern type of productivity, all of those things you can do in Azure. Again, that makes it so that you can get more agility moving forward. So some of the details in doing a transformation, these are the kinds of things that we would look at and how to address those in Azure. They range from everything from mainframe compute. As I mentioned, there's a lot of different what they call engines, or they're really processors on the mainframes. General purpose IFLs, that's integrated facility for Linux. ZIP, that's Z integrated information processor. Essentially, that's a database specialty engine. We can take those and provide similar things in Azure. Mainframes are divided into things called LPARs, logical partitions. Think of those as VMs. So you can take an LPAR and pretty much map it out to something like a VM, or map it out into a Kubernetes cluster, depending on how you want to do things in Azure. Again, I've already gone through the multiple OS environments. High performance storage. Online storage, basically in a mainframe, is called DASD. Well, we would use something like Premium or SSD or Ultra SSD to provide the similar type of capabilities. All those languages that the mainframe has, we could basically do convert those. For instance, Rex, you would probably convert. That's a scripting language, or you would perhaps just want to keep running it. So there's solutions to run COBOL and Fortran, but there's even solutions to run assembler, which is very low-level language written on that. There's high performance networking that's available in Azure. We do have RDMA in Azure, which would be similar to hypersockets on the mainframe. And then we can get to scale out computing. We do certainly, that's what clouds do. And then we can take most all of the data files that come across from the mainframe too. So this just gives you an idea of what a mainframe, at a high level, what it looks like. And then, well, this is what it might look like running in Azure based on the tools that you would typically have for, that type of a system. So, you've got everything from KICS and IMS, which are the transaction monitors, the batch, the various languages that you're running in. And then, but you also have things like schedulers. They do a lot of printing, even though it's probably now going to PDFs or something. Do a lot of sorting. You've got archiving on tapes. All those things could be mapped into capabilities that we would then run into Azure with tools. And then you could either keep the interfaces that are the same. TN3270 is the classic mainframe green screen. Or you could move that into more modern interfaces. For instance, Node.js or React. We see people, do those as they're moving into Azure as a migration option based on some of the frameworks that partners have for providing that. So I did briefly want to give, a little bit more of a architecture, what it might look like on Azure. So as you're coming into, this is some things we've actually done for customers. So these are, this is two different customer solutions. One of them where it was refactored into Kubernetes, and another one where it was kept more or less as is, the COBOL brought over as is. The difference between the two is that you need an emulation piece, which is this piece right here, to then provide the type of service for CICS or IMS that is running in Azure, so you don't have to change the code. So this particular one is also showing if I was using coupling facility, how do I keep memory sharing between? I could do that with Redis cache, or I could do that with RDMA, depending on what is my latency requirements. Now, keep in mind, RDMA is only available on a certain number of VM SKUs, so you have to be aware of what your target needs to be. As far as databases coming across, you can either have it into regular relational databases, or you might even use something like a NoSQL solution. So for instance, on a mainframe, you've got something called VSAM, that's a virtual sequential access method. That is, when it comes down to it, is more or less a key value pair. If I want to refactor that, then I might well want to target that into Cosmos DB, which is a NoSQL solution, which again supports, is a schemaless type of interface that I could support with NoSQL. Whereas also VSAM doesn't really have a schema per se, because you can redefine its usage any which way you want to. So there's different capabilities depending on what your systems require. And then either way, you can wind up with a solution that can then be hosted in Azure. And remember, I said that the larger systems, if I've got 100,000 MIPS, I'm probably not doing everything the same way. Some systems I might want to refactor, some systems I might want to rehost. So therefore, it's not an all or nothing decision. I can go either way if I needed to, as I'm moving across from a mainframe into Azure. And then a question that I often asked is, well, okay, well, how do I compute what the, how do I know how much compute do I need on Azure versus what I was doing on the mainframe? Remember, we talked about MIPS being how compute is measured on a mainframe. Well, there was an actual study done with one of our partners. This was done with on-premises, but it's also been, it was published by Gartner, but it was also, it's been duplicated in Azure And essentially, we find that at least for this particular benchmark, which was based on TPC-E, we were getting about 170 MIPS per core on x86 for batch processing, and about 288 for online. Now, my own personal recommendation is be a little bit more conservative and say somewhere in the neighborhood of 100 MIPS per core if it's COBOL applications. If it's things like assembler applications, I would probably drop it down to 100 MIPS per core because assembler is just that much more, it runs that much faster on a mainframe. So we do know how to map these things. So that gives us the ability to come up with some estimates on what some things would look like. So this has how you might want to take and move across a production, pre-production, and dev test workload that maybe started with 8,000 MIPS. That's a typical medium-sized mainframe. And then maybe some of the cost comparisons when it's then mapped over to what Azure VMs and PaaS services might be running with this. Now, again, I'm sharing these slides so you can go in this in more detail. I don't have enough time with this session to go into detail, but be happy to follow up with the specifics of this. So with that, the summary that I would like to get to is that we do have sort of sample mainframe journeys. So we do consider it a journey. So we need to have an inventory of what you're running and what your goals are for how you want to get there. In other words, do you want a rehost? Do you want a refactor? Do you need a combination? We do need to analyze everything that's out there, like your online. I forgot to mention JCL, Job Control Language. That's how you run things in the mainframe. And if you're trying to keep COBOL intact, you need something that can still run the JCL. As also mentioned, a mainframe probably has these specialty engines like running ZVM, or Z-Linux or zips. So we need to know what all those are and allocate for them. You can move your current DB2, that's the typical IBM database, over into Azure. Move your DevOps over. You can identify applications that are running the highest CPU consumption. Probably those are the ones you want to migrate either first or last, depending on their complexity. You do them first if you want to get the most bang for the buck. You do them last if they're the most complicated. So sometimes a database might be one of the things you would do earlier. It's less complicated from a migration perspective. So you do need to target and replace them, get them moved over into your systems. We maintain those hybrid connections as long as it's needed. And again, Microsoft, I think, is uniquely positioned to do that. And then finally, exploit what Azure has. You've got it on mainframe into Azure. You have the ability to run all sorts of analytics and things like that probably weren't easy to do on your source system. And with that, I just have a slide that you all can get for further content when you download the presentation. And with that, I think I'm pretty much done and out of time. So I'll turn it back to Ron.